Okay, so in the video, you see they give us this equation, dp over dt equals kp, right? So this p here is the variable, right? That's the variable. Of course, t is a variable in terms of time, right? So how will we solve that? What's the first thing we need to do? We want to separate our variables, right? So this would be dp equals k. The p is going to go now below there, right? And then dt is over here. Remember, this is a constant. This should be seen from over here real quick. So now what do I do? You're going to integrate, right? We're going to integrate both sides. When we integrate this side over here, we're going to get the natural log of p. And what do we get over here? Kt plus c. And now I don't like that logarithm thing there, so what do I do now? I'm going to exponentiate both sides. Okay, so this is going to be plus or minus p equals ce to the, okay, there we go. And then, of course, this plus or minus doesn't really affect that c. So we get this equation here. You guys are probably more familiar with it looking like this. So all of this is the general solution, right? The general solution for our differential equation that was given right here, which was given in the video. This model is exponential. It's an exponential model, which, like when you think of bacteria grow exponentially. But there's somewhat of a flaw of that, right? Can something just, can any population, like for example, can the human race just keep continuing to grow exponentially? No. What prevents it from doing that?
Lack of natural resources.
What do we call that? Once we get to a certain point where we can't sustain any more people, we have a special name. It's more of a biology or sciencey question. You guys, I'll give you the initials. Who's ever heard of that? Carrying capacity. Have you guys ever heard of that?
Yes.
Wasn't that in the notes?
Yes, it is in the notes, but it's the carrying capacity. Now, so the problem is, you know, if you're, I don't know, let's say you've got a certain amount of land and you're trying to raise, I guess, I don't know, let's say cows, your grass can only support so many cows. You can't have infinitely many cows. So there's this thing called carry capacity. Okay? So that's why this differential equation, by the way, you guys would agree that this differential equation looks a way more complicated than that one, right? Do you guys know what the solution is for this one? Y equals L over
It's an A plus
1 plus
B
E
KT
to the negative KT.
negative.
This is the general solution for this particular differential equation, which, how many of you have watched my awesome video that I posted on logistics equation? So Emmy has, and you all have? Okay, good. Hunter, you have, right?
I have not.
Okay.
But I understand.
Here's the thing though, in that video, I do how many I actually do this.
I thought so. When I saw
Holy cow. Did you see that? That was hard. Like I practiced that. And I even introduced something called integration by something called partial fractions, which is something that we're going to learn later on this semester. Yep, it's not as hard as it seems. Once we practice it, you'll be okay. But anyways, so, you know, last year when you were in pre-calculus, you dealt with this a lot. I skipped this section this year. Okay, so this year we're focusing on the logistics equation, which is a little bit more advanced. So this is it. Now, just to make sure that we're clear, the L is the carrying capacity. That is the limit of what that area or whatever will support in terms of, let's say, if we're talking about cows, the limit is it can only support, let's say, 500 cows. Once you hit 500 cows, it can't increase. You can't go beyond that. All right. In fact, if you put more than 500 cows in that area, guess what will happen to the population?
It'll start to decrease.
It will actually decrease. Okay. So that's kind of the interesting thing. This right here, this is the population at any given time. Now remember, this is the general solution. So most of the problems that you do where you actually have to solve things, you guys are going to have to figure out what this constant is, and you're going to have to figure out what this constant is.
That was typically given.
Okay? L is typically given in the problem. Okay? Now, when you graph this curve, typically, usually you start below, it goes up, and then it's going to level off. And again, what are we going to call that amount where it levels off?
Carrying capacity.
That's the carrying capacity. So we're going to say, like right here, here's our carrying capacity L. This is the nature of the curve. So it does grow exponentially, but then it starts to actually, it's still growing, but it's growing slower until it reaches its carrying capacity. So this is section, I think it's 5.4, logistics equation. So I derived it in my video, and then you guys have got to not memorize. You got to manipulate it and work with it. So, okay. All right.